Hello. Hello.
Yes, ma'am, we can hear you. Sheetal ma'am, your microphone is off.
Okay.
Okay. Good evening, everyone. Welcome to the e-faculty development program. Today's session is on time series analysis on the platform of eViews. And we have Dr. Sunita Arora as a resource person for today. She is Associate Professor with Government College of Women, Rohtang. She is very popular among researchers due to her knowledge and helping nature, and because she keeps on conducting such kind of workshops. So as I've already requested in the chat that all the participants, can you please keep e-views and the files ready, which ma'am has already shared. So over to you, ma'am. And we are really grateful at Geetharathan that you have accepted our invite, and you are here to enlighten the participants with your knowledge and wisdom, ma'am.
Thank you.
Thank you.
Thank you. Hello, participants. Today's topic is multiple time series regression with eViews. I'm Dr. Sunita Arora. I have been transferred to Government College for Girls, Sector 14, Gurugram, from Government College for Women, Rohtang. Presently, I am working with Government College for Girls, Gurugram. Yes. References on which I have based my 2 days lecture, 2 days sessions are Basic Econometrics by Damodar and Gujarati. Second one is most popular book for financial econometrics. It's Introductory Econometrics for Finance by Chris Brooks. Third one is Applied Econometrics Time Series by Walter Anders. And fourth is Econometrics by Example by Damodar Gujarati. Though all of you know about it, types of data. Let me revise in brief. We have 3 types of data. First one is cross-sectional data. Second one is time series data. And third one is panel data. What is cross-sectional data? Data on one or more variables from more than one units but collected at same point of time. Means time is 1 but number of units are more than 1. Variables may be 1 or more than 1. Let's discuss it with an example. For example, we collect primary data. It may be on one variable or more than one variable. We collect data only on the age of our students. It is on one variable. Age as well as their height. It is on 2 variables. Then number of students. These are our units. Means we collected data on more than one variables, more than one units, but same point in time. Means for once in a year, in a month, or any other time period. Time period is 1, but units are more than 1. Variables may be 1 or more than 1, but units should be more than 1. Means number of students should be more than 1. Then it will be called cross-sectional data. Second one is time series data. In time series data, we collect data from one unit, but for more than one time period. For example, we collected data from one student that how many hours he or she spends on reading per day. We collected data from one student on number of hours he or she spends on reading, but for more than one day. We collected data for consecutively 30 days or 20 days or 10 days or 360 days. Means periods are more than one. Time periods are more than one. But unit is one. Means we have collected data from one student. Variable may be one or more than one.
Please make your typical presentation.
Hello. I am presenting my PPT.
I am telling that make it in a presentation mode.
Presentation. Slides.
Yeah.
On slides. Okay. Yeah, I have not shared the slides. I will be sharing today evening, because if I share in advance, then participants are focused on PPT rather than on my discussion. That's why
I am requesting you what you are showing from your own system, make it in presentation mode. It is running in the normal mode. F5, you please click F5, it will be in presentation mode.
File, okay. But present,
right.
This one.
Right.
This one. Okay,
Yeah.
okay.
Thank you.
Okay. Yes. Third one is panel data. It combines feature of both cross-sectional as well as time series data. Means we collect data for more than one time period and from more than one units. Again, variable may be one or more than one. Basis of differentiation is number of units and number of time periods. If number of time period is 1, units are more than 1, then it will be cross-sectional data. Unit is 1, time period are more than 1, it will be time series data. Then units are more than 1, time periods are more than 1, then it will be called panel data. Yes. In 2 sessions, today as well as tomorrow, we will be analyzing time series data. Some issues that are addressed by analyzing time series data are, examples are, share prices of a company for one day are affected by prices of previous day or not. Generally, we see that market is related to its previous day performance. Generally, not always, but generally, prices are related to their previous counterpart, previous day prices. Then we may be interested in knowing whether GDP causes money supply or money supply causes GDP. Third one may be spot prices of an asset lead its future prices, or there may be reverse relationship, means future prices lead spot prices, or there may be feedback relationship, means sometimes spot prices lead futures prices and sometimes futures prices lead spot prices. Next, we may be interested in knowing share prices of one company are more volatile than the share prices of other company. Next, we may be interested in return or volatility for Monday or any other day is more or less than return or volatility of other days. Except last question, we will be answering all the above questions. 1, 2, 3, 4. Means in these 2 days, we will be answering these 4 questions. Yes. Which models are applied on these questions? Sorry. We will be answering the 5th question, not the 4th question. First question is answered by applying auto-regressive model, AR model or ARMA model or ARIMA model. Second question may be based on Granger causality or VAR. Third may be on error correction model, and fourth arch family of models, and fifth is dummy variable regression. Yes. Before analyzing any time series, first thing is to graphically present the data. Walter Anders, author of famous book Applied Time Series Econometrics, says that while analyzing time series data, our purpose is to detect what is data generating process, means how the data has been generated. Because if we are able to detect data generating process, then we will be able to forecast the time series. And generally, the purpose in time series is to forecast. Generally, not always. Generally, it is to forecast. So, firstly, we graphically present data. Always present data graphically. First purpose is to detect outlier. Outliers in time series may be detected through graph as well as through histogram of residuals. We will be doing the second step also. Then, why we graphically present the data? To detect outlier as well as to check whether data is stationary or no. Though formally it is checked by applying tests, unit root test, but generally the base of unit root test is always graphically presentation of data. What is stationarity? Why to check the stationarity? Stationarity means, in weak form of stationarity, it means whether our time series is mean reverting or not. Means it is frequently crosses its mean or not. And second is covariance of different autocovariance of different time periods. Means if we divide our data into different parts, into different time periods, then variance or autocovariance should be same. If these conditions are met, then we can say that our series is stationary. Why to check stationarity? Why we are interested in stationarity? Because time series models are based on the fact whether our series are stationary or no. If series are stationary, then models are different. If series are not stationary, models are different. If series are mixture of stationarity and non-stationarity, then then models are different. Yes. This is the example of one graph. See, one date means this one, 10th June 2013. This value is an outlier because series is moving generally upward, sometimes downward, but generally upward. But this value is far away from the adjacent data points, one before and one after. It is far away from the data points. That is why it is called outlier. Yes. If two time series which are non-stationary and we apply simple regression on non-stationary time series, then relationship will be spurious, means there is no actual relationship, but our results will be showing that there is relationship. R square will be higher than Durbin-Watson. What is Durbin-Watson? Durbin-Watson is a test statistic which detects first order autocorrelation. What is autocorrelation? Correlation, linear correlation means correlation between two variables. I am repeating. Correlation between two variables is called linear correlation. But correlation of a series with its previous values is called autocorrelation. Means, for example, prices of an asset are correlated to prices of same asset of previous days, previous 1 day or previous 2 days or previous 3 days. It will be called auto correlation. Or sales of a particular quarter may be related to sales of that quarter of previous year, same quarter of previous year, or sales of a quarter is correlated with sales of previous quarter, then it will be termed as auto correlation. If R square is greater than Durbin-Watson, then we may say that regression is spurious regression. It is not actual regression, but our analysis is showing that there is relationship between two variables. Example is salary of bank employees in India and death rate in Iraq may be correlated, but there is no underlying factor. Because of that factor, these variables must be correlated. That is why data is showing that these are correlated. Analysis is showing that these are correlated, but these are actually not correlated because both may be increasing or decreasing with the passage of time. Then, if non-stationary time series is regressed on another non-stationary time series, then results cannot be generalized. Those results will be applicable only on that particular period. These cannot be generalized for other periods. That is why we are interested in checking the stationarity of data. Yes. How to check stationarity of data? First one is time series plot, means we will be graphically presenting the data. If time series is not stationary, then it will not hover around its mean. Means if time series is stationary, then it hovers around its mean, means it crosses frequently its mean. A stationary time series crosses frequently its mean. A non-stationary time series doesn't cross frequently its average value or mean value. Second one is how to detect. It is autocorrelation function or correlogram. With the help of correlogram, we may check whether our series is stationary or not. Correlogram shows the autocorrelation, the term I was discussing just then. Third one is formally applying the test, means unit root test. What are unit root tests? Unit root tests tell us if we regress time series on its previous values, then coefficient will be 1. I am repeating, coefficient of independent variable will be 1. Unit root test tell us that coefficient will be 1. Most popular unit root tests for time series data are augmented decay filler test and KPSS test. Null hypothesis for both these tests is reverse. Augmented decay filler test has the null hypothesis that series is non-stationary. Series has unit root, means series is non-stationary. I am repeating. Null hypothesis of augmented decay filler test is series is non-stationary. Series has unit root, means series is non-stationary. Whereas null hypothesis of KPSS test is series is stationary. Generally, both of these tests are popular to cross-check with the help of augmented decay filler test, ADF test, popularly known as. We check if null hypothesis is not rejected, means series is non-stationary. Whereas in KPSS test, if null hypothesis is not rejected, then series is stationary. Non-stationary time series. Another name of this series is exploding, means series is exploding continuously. Either it is increasing or it is decreasing. It is exploding. Or unit root, already discussed by me. Stationary time series. It is an example of stationary time series. Other name given to stationary time series is non-explosive or mean reversion. Means it is not exploding. It is reverting to its mean. Frequently reverting to its mean. See, in this graph, generally the average is 0. This line, thick line, it may not be visible to you, but when I'll be sharing the presentation, it will be visible to you. It is our mean value. This 0 point, it's our mean value. Series is hovering about it. It's reversing to its mean frequently. It may be stationary time series. Graphically, we check whether our series is stationary or not. Then we may detect whether there is any outlier or not in the series. This point may or may not be outlier. Yes. This is the correlogram of non-stationary time series. I am repeating. This is the correlogram of non-stationary time series. Generally, in this correlogram, first period partial correlation. What is partial correlation? Partial correlation means correlation between two variables by controlling the effect of other variables. I am repeating. Partial correlation means correlation between two variables by controlling the effect of other variables. It is partial correlation. In time series data, partial correlation means correlation between two time periods by affecting the by controlling the effect of other time periods. In time period 1 means correlation between, I am talking about partial correlation, correlation between variable with its just previous value. It is first period partial correlation. Second period partial correlation means correlation between present and day before yesterday. Today and day before yesterday means not yesterday, day before yesterday, controlling the effect of yesterday. It is the partial correlation between 4 lag 2. It's called lag. Day just yesterday means lag 1. Just previous value means lag 1. Previous to previous value means lag 2. Thursday with Monday means lag 3, means previous 3 periods. In time series, it is called lag. Partial correlation of non-stationary time series is significant only for period 1, generally, only for period 1. It is called non-stationary time series. And autocorrelation, it is decreasing. See the values, autocorrelation, these are decreasing. In the values portion, we see first value is 0.998, second is 0.995, third is 0.993, 0.990, means it is decreasing. If we see this type of parallelogram, then we may say that our series is non-stationary. Yes, parallelogram of stationary time series. No high spike in autocorrelation or partial correlation. There may be some spikes, but those spikes are not high. Those may be significant, but not near to 1. Regression equation of augmented Dickey-Fuller test is, it is the symbol of difference, means series has been differenced. Difference means past value, previous value has been subtracted from the present value. I am repeating, previous value has been subtracted from the present value. Then the series is called difference series. Yes. Difference of yt. Why this small t? This t shows that we are analyzing time series data. If subscript is I, it shows that we are analyzing cross-sectional data. It is T, means we are analyzing time series data. Delta YT, delta means difference. Delta YT is equal to beta 1. Beta 1 means it is intercept, because it doesn't have any of the independent variable. It is intercept. Beta 2t. This t shows the trend in the data. If there is trend in the data, then this t is introduced. If there is no trend, then this t is not introduced. Then again, t minus 1, coefficient of y t minus 1. This coefficient, because series has been differenced, we are interested in this coefficient. If this coefficient, if we include only these values, note next portion, then it is called Dickey-Fuller test. If we include the lags of values also, then it is called augmented Dickey-Fuller test. Firstly, Mr. Dickey-Fuller introduced simple Dickey-Fuller test, introducing as independent variable only the previous lag, means only previous value, not more than those values. But after some time, he introduced delta of previous values also, previous lags also. He augmented his test. That is why this test is called augmented Dickey-Fuller test. Yes. Now, transforming non-stationary time series to stationary time series. We may have two types of stationarity or non-stationarity. One is difference stationary or second is trend stationary. Let me first show you the graph. Sorry, there are no graph. Yes. Non-stationary time series. If the non-stationary time series is difference stationary, means there is a trend, but that trend is not high. Value is significant, but not close to 1. Coefficient of trend means this coefficient B2 is not close to 1. Then we may say that series is difference stationary. But if it is this B2 is near to 1, we may say that series is trend stationary. How to difference the series or transform the series to make the series stationary? We have two methods. First is simply differencing the two values. Second is differencing log values. Simply differencing, if we have ratio data, then we prefer simply differencing, means subtract the previous value from the present one. If we don't have ratio data, we have simple values, prices or any other value, then we generally convert to log data. In financial time series or economic time series, we generally convert the values to log. Then we subtract log of previous value from the log of present value. This one is theoretically last topic. Then we will be doing practical along with theory. Which different type of models are applied on non-stationary or stationary time series? If series are stationary, then we apply OLS, means ordinary least square. Simple regression means, or ARIMA or Granger causality or VAR or arch family of models. Depending on the nature of data and objective of the study, any of these model will be applied. It will depend what is the objective of our study. If both of our series are non-stationary, then we apply co-integration test and error correction models. And if we have mixture of these series, then we apply, means some series are stationary and some series are non-stationary, then we apply ARDL model, a topic to be covered tomorrow. Yes. Let's do practice. Open the eViews. Open the eViews. Go to File. Go to File. Open foreign data as work file. I have shared with you these three Excel files: currency books data, matched data after deleting outlier, and table F5 to green. Today we will be doing analysis with matched data after deleting outlier. You may have more than one worksheets in your work file. Then how to select the required sheet? This is from here. We have data on sheet 1. We have data on sheet 1. That is why we are selecting sheet 1. If we may have data on sheet 2, then we will be selecting sheet 2. Yes, select sheet 1. I am repeating. Open your eViews. Go to File menu. Open foreign data as work file, because we have Excel work file. That is why we are opening foreign data as work file. Then open matched data after deleting outlier, or currencies books data file. Firstly, we will be working with matched data after deleting outlier. Just finish. No. Yes. This page of eViews work file is showing that you have these variables. First variable B, beta. C, it is constant, it is intercept. In the starting, when we open any work file, two variables are introduced by eViews automatically. This one and this one. See, this is the intercept. Presently, if we open this series, just double click on it. To open the series, just double click on it. See, it is 0, 0, 0, 0, 0, because we have not applied any regression. That is why intercept is 0. Then residual. What is residual? Residual means difference between expected value and observed value. I am repeating. Difference between actual value and expected value and observed value. It is called residual. We have not applied any regression, means no expected value. We have only actual values or observed values. If we open residual, it is showing NA. See, NA, because we have not applied any regression. If we will apply any regression, residuals will be saved in this variable name, under this variable name. If we apply second regression, these residuals will be automatically updated. Yes. Other three variables we have in our work file. in our Excel work file. These are date, futures, and spot. First of all, we will be checking whether there is any outlier in the series or not. Open the series future. I'm repeating. Double click and open the series futures. View graph. View graph. Generally, by default, in time series data, it selects line and symbol because we are interested in line graph. Then sometimes it shows here connect adjacent. We may check it or we may not check it. Sometimes this is in gray. Why? If we have some, I'll not be saying missing points, some missing dates, not missing values, missing date. For example, this is 1st January 2009, 2nd January 2009, 3rd January 2009, then 5th January 2009, 6th January, 7th, 8th, 9th, 10th, and then 12th. Means 4th and 11 are missing because these were, I think, Sunday, and on these days trading was not done. These are not missing values. Missing values are those values if we have data point but we can't collect. There is some data point but we couldn't collect that data point. That value is called missing value. But on 4th of January 2009 and 11th of January 2009, there was no trading. That is why these are missing dates, not missing values. If we have missing dates, then EVS will be showing this connect adjacent. You may check it or not check it. If you don't check it, see, graph will look like this. See, on different dates, there is some cut, means there are some missing dates. If we go to options, connect adjacent, see this graph, there are some cut, there are some gap. But if we connect adjacent, this gap is filled. It connects the adjacent values. Yes, what we see in this graph, there is any outlier or not. Two things we check in graph. First is outlier and second is structural break. What is structural break? For example, series is going upward, then series go flat, then series go downward. Sorry. It is called structural break. Means there is drastic change in the behavior of series. It is called structural break. And if some value, one or more values are very far away from the adjacent data points, then that data point is called outlier. We will be checking in the series whether there is an outlier or whether there is an structural break or no. In this series, we may say that there is no outlier or no structural break, or we may assume this as break point. May assume because up to this series was going upward. After this, it was upward downward trend, then upward trend, then downward trend. This may be treated as structural break because after this the series is going downward continuously may be treated because it is not clear whether it is an outlier or not. Yes. Next is, let's check spot. View graph, next adjacent. Okay. Behavior is almost same for spot value and futures value because these are the values for same asset, future value and future prices and spot prices for the same asset. That is why behavior is almost same. Let's formally check whether series are stationary or not. I'll be checking only one series. Any of the series, futures. View correlogram. I am repeating, view correlogram. Press OK. This correlogram. First partial correlation. It is approximately 1. First value of correlation, autocorrelation and partial autocorrelation are always same. I am repeating, first values of autocorrelation and partial autocorrelation are always same because in correlation with first lag, we can't control intermediate lags because there are no lags. First lag means with previous value. There are no lags in between lags, intervening lags. That is why value of partial correlation and autocorrelation, these are same, 0.998, 0.998, and these values are highly significant. See, autocorrelation value is decreasing. It is decreasing continuously, and partial correlation, it is significant only for one period. How to check whether value for other periods is significant or not? Just rotate your laptop on 90 degrees. I'm repeating, just rotate your laptop on 90 degrees. It is, you have two dotted bounds. I rotated left hand side. Then you have two dashed, no dotted. These are dashed lines. You have two dashed lines. Left hand side, or after rotating your laptop, downward line is lower bound and right hand side or upward side is upper bound. We have two bounds for partial correlation. None of these values is significantly crossing the lower bound and upper bound. I am repeating, none of these values is significantly crossing the lower bound and upper bound. That means we may say that only first value of partial correlation is significant and other values are not significant, and values of autocorrelation, see, these are decreasing continuously. Clear? Then we may say that series is non-stationary. I am repeating, if only first partial correlation is near to 1, it is near to 1, and other values are not significant in partial correlation, and in autocorrelation values are decreasing, then we may say that series is non-stationary. First we check graphically presenting the data, then we check with the help of parallelogram. Third one is view unit root test. View unit root test. I am repeating. On the series window, it is series window. View unit root test. Most popular are, I already told you, these are augmented decay and KPSS. Augmented decay, then level, yes, level. Include in test equation, intercept and trend and intercept or none. Which one we should include? It will be based on the graph. See the graph of the series. What was it showing? There is some trend in the series. There is an intercept as well as trend in the series. Then we may check intercept and trend. I am repeating. How to decide whether in augmented decay test include only intercept and trend, or none of these. Out of these three options, which one to include? First, second, third option. It depends on the graph of the series. Intercept means there is only intercept, but there is no trend in data. Trend and intercept means there is intercept as well as trend in data, or none means no intercept, no trend. We will be going for trend and intercept. Okay. Yes. It automatically selects the lags. See, view, unit root test. Which were the lags? Augmented in decay test, no lags were included. But in I already discussed that in augmented decay lags were introduced by decay. Yes. How many lags to include? Most important question in time series data, how many lags to include? How many lags to include means series is correlated with how many past values. Lags means past values. Series are correlated, or two, if we have two series are closely affecting how many lags, means how many previous values. Lag selection is most important. And how to select lags? EViews generally automatically selects lags on the basis of some criteria. These criteria, most important criteria, widely used criteria are such large information criteria and Akakai information criteria. These two. If we base our research on literature, then Walter Anders say that you should go for criteria such large or Akakai information on the basis of your sample size. If you have large sample, then go with such large information criteria. If you have small sample, then go with Akakai information criteria. We have large sample, we have many values. That is why we are going with such large information criteria. Clear? It will automatically select the lag. Or if we know how many lags to include, then we may user specify. Here you may specify 2 lags, 3 lags, 4 lags, 12 lags as you think fit. Yes, I'm going with such large information criteria. I'm saying the reviews that on the basis of this criteria, you select how many lags you want to select. Yes. Okay. Yes. it has selected 0 lakhs. 0 lakhs of, see the presentation we were discussing. This one was these lakhs. These lakhs. Lag of delta by t minus 1. It is saying, EVUS is saying, no need of these lags, which augmented decupiller introduced in our case in the series futures. No need to introduce any lag. I checked on the basis of SIC. You told me that check up to 24 lakhs. We have daily data. We may ask him to check 6 days because in daily data, generally there are 5-day or 6-day working. So we may say that check so many lakhs. It checked 24 lakhs. Lag selection criteria was SIC. EVU selects on the basis of minimum value of SIC. What is SIC? It is generally compared to residual sum of square or ESS in regression, because we know that we want that a residual sum of square should be minimum. So in the same case, same way, in time series data, we want that our SIC should be minimum. Automatically selected on basis of SIC. It automatically selected on the basis of minimum value of SIC. It selected how many lakhs? 0. Then what are the results? Null hypothesis is futures has a unit root. I am repeating. Null hypothesis is futures has a unit root. Means futures variable future R series future is non-stationary, and on the basis of p value, this null hypothesis cannot be rejected because p value is greater than 0.05. I am repeating. Null hypothesis is futures has a unit root, means our series futures is non-stationary and probability value is 0.8944 greater than 0.05. That means we cannot reject the null hypothesis, means our series is non-stationary. You may cross-check with the help of KPSS test. Yes, KPSS. Okay. Again, what is null hypothesis? It is stationary null hypothesis. Null hypothesis is it is stationary. It has calculated, it is not giving us p value. It is giving us the values. These are our calculated values and these are the critical values. Our calculated values 0.987243 and 5% value is 0.146000, means our calculated value is higher than the table value. I am repeating, our calculated value is 0.9872 and table value is 0.146000 at 5% level of significance. So our calculated value is higher than, greater than table value. So in this case, our null hypothesis is rejected. Futures is stationary. Null hypothesis in this case is futures is stationary, and this null hypothesis is rejected. Means we have cross-checked that our futures series is non-stationary. In the same way, you may check whether the sport series is stationary or not. You will be checking and you will find that this series is also non-stationary. Both the series are non-stationary. If we regress this, how to apply regression in EViews? Steps of applying any regression in EViews. Go to quick, go to estimate equation. I am repeating. Go to quick, then estimate equation. Write your dependent variable, space. If you want to introduce intercept, then C space your independent variable. No need to write plus minus. I am repeating. Futures space C space sport. Okay. C. This coefficient is significant. Sport, this coefficient is also significant. Whether we should interpret these results or not. Check R square. Generally in stationary time series, R square is very low. But in non-stationary time series, if both the series are non-stationary, R square C is higher than Durbin-Watson. R square 0.99 and Durbin-Watson is 0.22. I told you, if we regress a non-stationary time series or non-stationary time series, then if we regress non-stationary time series on non-stationary time series, then our results will be, our regression will be spurious regression. And we look on the basis of values of, see this slide, I told you how to check whether our regression is spurious or not. How to check? One check is, if R square is greater than Durbin-Watson, then we may say that our regression is spurious. We should not interpret the results of this regression. See, in our results, R square is 0.99 and Durbin-Watson is 0.22. Means these results should not be interpreted because we have regressed non-stationary time series on non-stationary time series. If we are interested, we may regress stationary time series to stationary time series. How to convert a non-stationary time series to stationary time series? I told you that we have two methods. By simply differencing the series, or by log differencing the series. When we prefer simple differencing and when we prefer log differencing. Simple differencing is preferred when we have ratio data. Then we prefer simple differencing. If we have simple data, not ratio data, then in financial and economic time series, we prefer log differencing. In this case, we have futures, these are values, not ratio, spot, these are also values, not ratio, then we will be differencing by log. Go to generate, and one more thing, I have given you this 5 important points. I have shared these important points. See these highlighted values. We have two types of return. If we have values, if we have prices, we have two types of return. First is simple return and second is continuous return. First is simple return and second is continuous return. Simple return is calculated with the help of PT minus PT minus 1 divided by PT minus 1 into 100. How it works? For example, we invested 1000 rupees and after 1 year, this value of the asset is 1200. How much we earned? We earned 200 rupees. 1200 minus 1000. Then how we'll be calculating the return? We earned 200 by investing 1000. Means we will be dividing this 200 by 1000, our initial investment, then that will be multiplied by 100. It is return. Second one is continuous return. What is continuous return? Generally compound return is known as continuous return. It is preferred in financial time series. It is calculated as log PT minus log PT minus 1 into 100, or simple is log P by PT minus 1. So, in E-views, it has simple formula. Generate F return, means future return, or any other name you want to give your series, is equal to D log within bracket futures, bracket close, multiply by 100. F return or futures return or any other name as per your wish you may give to your series. It is equal to D. D means difference. Log means take the log of futures, then difference the series. See this. We have taken the log of series PT and PT minus 1 and we have difference this, and then we have multiplied by 100 and it is continuous return. In ABO's formula is D. D means difference, log means log. Take the log of futures, then difference the values and then multiply by 100. Okay. We have a new series F return. Let's check whether this series is stationary or no. Go to view, graph, connect adjacent. Okay. See. This is the graph of futures return series. This is the graph of futures return series. It may be stationary time series. Why it may be stationary time series? Because it is hovering about its mean. It's crossing its mean frequently. That is why we can say that this series is stationary time series. Again, view parallelogram. Okay. See, No value is significant, means it is stationary time series. Then in the same way, we calculate spot return. Go to generate. S return is equal to B log within bracket spot bracket close into 100. Okay. Again, we have new time series, new series S return. View graph connect adjacent. Okay. Yes. This is the graph. It is also showing that it is stationary time series. View parallelogram. Okay. Same are the results. Then we may also apply unit 2 test. First difference, only intercept because there is no trend in this data. Which test to apply? Augmented decay filler. Null hypothesis is series is non-stationary. Okay. S return is non-stationary. Null hypothesis is rejected. Means this series is stationary. Now we have two stationary time series. Futures and spot. Generate, estimate equation F return space C space S return. Okay, these are the results. C is not significant. C. R square is very low. Darwin-Watson is near to 2. It should be near to 2, but it is greater than 2. We will try to bring it to near to 2. Yes, these results may be interpreted, but because interpreting the result of any regression, whether cross-sectional data, time series data, or panel data, we should check residuals. In single equation model, I always prefer to check residuals. Means we will be checking assumptions. How to check the residuals? View residual diagnostic. Correlogram. We will be checking 3 or 4 assumptions. First assumption is that residuals should not be autocorrelated. I am repeating, residuals should not be autocorrelated. Correlogram Q stat will tell us whether our residuals are correlated or not. Yes, let's check. Correlogram Q statistic. Okay. See, first residual may be correlated. First residual may be correlated. Means we can't journalize the result. For this purpose, we may introduce AR term in the series. See, view residual diagnostic parallelogram Q stat. Okay. What is AR? We are applying ARMA model. AR terms, not ARMA model. We are introducing AR MA terms. What is AR term and what is MA term? See, I have written in the notes AR. What is AR? AR means auto regression. When we regress any variable on its own lags, it is called auto regression. Auto regression means auto, अपने पर, regressing on itself, regressing on the lags of the same series, means regressing on the lags of dependent variable is auto regression. MA. MA means moving average. When we regress any variable on the residuals on the equation, it is called MA process. Why residuals? Sometimes previous value is important and sometimes residuals are important. Why residuals are important? I already discussed that residual is the difference between observed and expected value. Sometimes this difference is more important than the other values. Means in this case, our case views, first values are significant. These are crossing these dashed lines. How to select whether to introduce AR term or MA term? How to decide? We will be deciding on the basis of this parallelogram as well as minimum value of SIC. Check. These on the basis of partial correlation, we significant value of partial correlation, we select lags of AR, and on the basis of significant values of autocorrelation, we select lags of MA terms. I am repeating, on the basis of significant values, this values crossing the dashed line. On the basis of significant values of partial correlation, we select the lags of AR terms, and on the basis of autocorrelation, we select the lags of MA terms. Yes. Let's check. Estimate AR1. I introduced AR1 space AR1 in the same model. Okay, let's check. What are the results? Durbin-Watson is 2.02. In the previous, it was 2.2. In this, it is 2.02. R square is not higher than Durbin-Watson. Yes, what is the value of SIC? 2.4723. Note down this value. Then introduce MA term, MA1. Let me note down this value, 2.4723. Yes. If I introduce MA term, then this SIC is 2.46. If I introduce both, hello, AR1 and MA1, then the value is 2.4652. Yes, now we will be comparing these all values. See, when I introduced AR1, value was 2.4723. When I introduced MA term, it is 2.4686. If I introduce both, it is 2.465. Means minimum value is in the case AR1, MA1. Yes. Let's check other assumptions. Hello, any issue with anyone? Hello?
Yes, ma'am. Yes, ma'am.
Yes. What's the issue?
So far, one or two questions has come up, ma'am, but you can continue with your presentation and we can ask questions little later.
Okay. Yes. Minimum value is when I introduced AR1 MA1, means our model on the basis of minimum value of AR1 MA1 is on the basis of SIC, it is AR1 MA1. Yes, let's check now residual. What is the status of residuals? Pornogram Q stat. Yes. See this. First one is corrected. Second one is corrected. Third one is corrected. Fourth one is also corrected. But seventh is significant now. This problem we are facing here because there is no dependent variable, because we have values of same asset, future price and spot price of the same asset. That is why we are facing the problem, because not only spot return is impacting the futures return, there may be feedback relationship. I am repeating, there may be feedback relationship between futures return and spot return. And second reason may be there may be outliers in the series. How to check whether there are outliers in the series? Yes. View residual diagnostic, histogram normality test. We don't expect normality in residuals of time series data. I am repeating again and again that we don't expect normality in the residuals of pornogram, but I am checking just for detecting the outlier. Sorry. Stat. These are the results. View residual diagnostic, histogram normality test, just to detect the outliers. See these values, this and this. Minimum value is -5, maximum value is 5. This may be the outlier, maybe, not exactly, but this may be the outlier. How to check whether this is an outlier or not? We may introduce this value, this 5. Let me check. See residuals. These are the residuals. Procure, procedure or procure, make residual series. Ordinary residuals, and I am giving the name it to residuals of futures on spot. RES residuals for futures, F on spot. You may give name as per your choice. Let me check. I'm sorting the series. Sort on the basis of residuals, ascending order. Okay. It is the minimum value. But highest value was looking for an outlier. This is for 30th November 2009. 30th November 2009. If we assume this to be an outlier, we may introduce dummy for this outlier. I am repeating. If we detect any outlier in the residuals, we may introduce dummy for that date. See, residual series is there. This is residual series and date is 30th November 2009. We may introduce dummy for this variable. How to introduce dummy? Sorry, 30th November 2009. Go to generate. I have given you the formula in the C outlier. This is for outlier, means on this particular date generate one new variable. Outlier is equal to at the rate of record within bracket at the rate of date is equal to date val You may copy this and change the date. You may copy this and change the date. I have given this value. Yes, our date in this case is, it is 30th November 2009. Yes. See, there is one variable for 30th November 2009. See, the value will be 1, and for other values, other dates, it will be 0. 30th November 2009. Sorry, it does not introduce the outlier. There may be some issue. Yes, let me check. It is record within bracket at the date is equal to date value 30th November 2009, then value 1, otherwise 0. So sending, sorry, sold on the basis of outlier is sending it has not introduced any outlier. Go to generate outlier. Is equal to, formula is at the rate of recode, at the rate of recode within bracket, there will be two brackets. One will be at the rate of date and one will be before date. Recode means recode the series. Which series? Date series at the rate of date. How to recode? Date on the basis of date value. If date value is 30th November 2009, then convert it to 1, otherwise 0. It is 30th November or 30th October? I don't know why it is not creating the new variable. It's the way to create. Yeah, it has created. For 30th November, the value is 1, and for other days, it is 0. Yes, we may introduce this in our equation. Quick estimate equation. R futures, it was F return, sorry. It was F return space C space S return space outlier. Okay, let's check our problem has been solved or not. 2.21 same means we have to introduce AR1, MA1. If this problem is not solved, then you may assume that there is feedback relationship. Feedback relationship means sometimes SR leads the FR and sometimes FR leads the SR. This is called feedback relationship. And to detect feedback relationship, we have two models, Granger causality as well as VAR. Yes, let's check. Maybe our problem solved. Yes. Okay. It's not solved because there is feedback relationship between the series. That is why it is not solved. How to check the feedback relationship? For stationary time series, to check feedback relationship, we apply var. I am repeating. For stationary time series, we apply var. And for non-stationary time series, we apply error correction model. If the series are co-integrated, yes, I am applying var. Which series? We have two series. F return space S return. Yes. How to select lag? Again, we will be selecting on the basis of, yes, one more thing, introduce outlier as exogenous variable because there was an outlier. Yes. Okay. How to select lags for var? EViews has lag structure, lag length criteria. Means we are saying it to select lags for us on the basis of minimum value. On the basis of minimum value of SIC, it has selected 5 lags. See this asterisk. It has selected 5 lags for us. So we will be introducing 5 lags for var. Yes, 5 lags. Okay. Yes. These are the results. These results are somewhat difficult to read. So we may go to view lag structure, lag, Granger causality, probe exogenicity test. I am repeating. First we estimated var, then we selected lag length criteria. On the basis of lag length criteria, we selected lags. Then we are finally checking the lead lag relationship. Means which variables is leading the other variable. See, these are the results. Dependent variable is f return. When dependent variable is f return and sport return may be excluded or not. Null hypothesis is this may be excluded. Null hypothesis is this may be excluded. S return may be excluded. Null hypothesis is rejected. Means it cannot be excluded from the regression of F return. Then what about S return? When sport return is the dependent variable, whether F return may be excluded? No. It also cannot be excluded. Means there is feedback relationship between sport return and futures return. I am repeating, sometimes futures return leads the sport return and sometimes sport return leads the futures return. Now, the same procedure let's do with currency data. Speedily, we will be doing this and then we will be discussing the problems. Let's check. Open the eViews. Open the eViews. Open the file. Foreign data work file. I have given you a file, currencies Brooks data file. I have downloaded it from the companion website of book Introductory Econometrics for Finance by Chris Brooks. Yes. We have three currencies, Euro, GDP and JPY. Let's check whether these three currencies lead the other currencies or not. Firstly, we have to check whether these series are stationary or not. EUR. Speedily, let's check. Unit root test. Okay. Null hypothesis cannot be rejected. Means it is non-stationary. Then GDP, view, unit root test. I am doing speedily because I have discussed the process. Already discussed the process. It is also non-stationary. Then third, view, unit root test. Third one is also non-stationary. We can't apply bar or regression equation on this. Yes, we will be converting these series to stationary time series. Euro, these are currency value in comparison to other, means these are ratios. So we are converting only by differencing, not log differencing, only by differencing, because these are already ratio. Ratio values are not converted into log difference. Yes, DEUR is equal to B within bracket EUR. I'm not taking the log because we already have ratio data. Yes, next is generate DGDP. This is second currency is equal to the difference of GBP bracket close. Okay, third currency generate DJPY is equal to D of within bracket JPY bracket close. Okay, now we have three currencies. Stationary currency, we are applying VAR on these because any one of these may lead the other. We are not, we don't know which is our dependent variable and which is our independent variable. With these all three variables, we will be applying VAR. How to open these three variables as a group? Highlight the first variable, press Control, highlight the second. By pressing Control, highlight the third. Right click, open as group, as equation, as a factor, or as var. Directly we may apply var on this. Yes. Just click OK because we will be selecting the lag length, lag structure, lag length criteria. Okay. It has selected one lag on the basis of SIC. I am repeating, it has selected only one lag on the basis of SIC and 4 lags on the basis of AIC because we have 7,133 observations, means we have large sample. So we will be going with SIC criteria. Yes. Estimate lag intervals only one space 1. Okay, we are not interpreting these results. We are going with view, lag structure, Granger causality, log exogeneity test. Now these results will be interpreted. See, it has continuously simultaneously applied 3 equations with us. First is dependent variable D euro. It is dependent variable DGBP and DJPY. These are independent variable. These may be excluded. May be excluded means are not significant. I am repeating. These may be excluded means these coefficient of these variables are not significant. Yes, including the lag values. Yes, these are not significant. Means euro may be leading the other two currencies for this data up to 2018. This data is from 14th December 1998 to 3rd July 2018. Yes. In the dependent variable DGBP, second currency, whether euro and Japanese yen, I think this is, these are significant or not? Yes, both are significant. Means these both are significant in the including the lag values of these variables. In the equation with dependent variable DGBP, these both are significant. Means these lead this value, this currency. These both lead this currency. In the same way, in Japanese yen, these both currencies are significant. Cannot be excluded means are significant. Means these are significant for dependent variable DJPY. Means this currency, euro, leads the other two currencies. Clear? This DGBP, it leads only one currency. Which currency? It is significant. Sorry. It is significant in the case of yen. Means these are the results and these results may be interpreted. Why we apply VAR? Because there is no single equation. We don't know in this case which one is our dependent variable. We asked the software, check which one is dependent variable and which other variables are leading the dependent variable. Means which are significant in the equation with these dependent variable. It simultaneously applied three regression models. First is this one is dependent, these two are independent. Second one is this one is dependent, these two are independent. Third one is this, all the variables one by one. It has taken dependent variable and other variables as independent variable. Yes, now the questioning time. Yes.
Yes, ma'am. I'll look into
Yeah.
the questions right. There is one question by Miss Geeta.
Yes.
She is asking, in education field, how we will apply time series.
In education field, I was, I don't know exact. I'll be telling you tomorrow the name. I think it is the book by Stroke and Watson. 99%. Times it is Econometrics by Stroke and Watson. Yes, exactly. It is the same book. He has applied in the education field. He
Oh,
checked whether students' grades are impacted by student-teacher ratio, then infrastructure, then composition of students. Means he applied time series cross-sectional data as well as time series data. He collected cross-sectional data as well as time series data and applied regression whether students' uh, grades are impacted by. You may collect data for for different time periods of particular state or particular district and take the average of grades and then check which factors leads or which factors impact the grades of other factors.
okay.
This is the way it may be applied. Yes.
Okay, ma'am. There's one more question by Dr.
Yes.
Gur Vishal. It's, Madam, which book you recommend to study for EVUs on time series?
Yes, its most popular book is Introductory Econometrics for Finance. Introductory Econometrics for Finance by Chris Brooks. Second edition is best if you want to go with EVUs. And it's I'm showing you its guide. EVUs guide is freely available on Amazon, but soft copy only. Introductory Econometrics for Finance, its soft copy. EVUs soft copy is freely available on Amazon.
Okay, ma'am.
Yes.
Uh, there is another question: how we can detect the correct lag structure by the help of autocorrelation and partial autocorrelation plots?
On the basis of, see, these are, I'm deleting the var and I'm selecting only lags. See, I'm selecting only one series. View, sorry, view parallelogram. Open the series, view parallelogram. Okay, these two are significant. First autocorrelation and first partial correlation. I'm repeating. See the significant values. How to check whether these are significant value? If these are crossing these dashed lines, left hand is lower bound, right hand is upper bound. If any of the value crosses the value, these bounds, then that value is significant. In this case, it was DEUR. Only first value is significant. Gujarati says that selection of lags for AR and MA is an art, not a science, but it is based on some logic. Means we select AR lags on the basis of significant value of partial correlation and MA on the basis of significant value of autocorrelation. This one and this one is significant. Now we have the combination of different models. Only AR1, MA1, AR1 and MA1. We have three choices. Then we will apply all these three, and on the basis of minimum value of SIC, we will select which of these three is the best model. I am repeating. Select the AR lag on the basis of partial correlation. Select the MA lag on the basis of autocorrelation. And then make the choices. How many choices we have? In this case, only first lag are significant in both the cases. Means we have choice among AR1 model, MA1 model, AR1, MA1 model. Then out of these three, which one to be selected on the basis of minimum value of SIC or AIC, you will select which model is best model. Yes, next question. I think it is clear.
Yes, ma'am.
Yes.
We have another question. Why didn't we calculate the log difference in the for returns for currency?
Currency, in this case, currency is ratio. Currency is the value of one currency in comparison to other currency. Means if we see the value of dollar in comparison to Indian rupee, it is ratio. And in case of ratio, we don't go for log values. Clear? In case of simple values, we go for log, but in case of ratio, ratio is already, if you have some knowledge of log, then it is not applied on ratio. Clear?
Yes,
It is applied on values, it is not applied on ratio, and currencies are already a ratio. Currencies are in ratio values. That is why I didn't take log while differencing the currency values. Yes, next question.
yes, ma'am. How time series is beneficial in knowledge management research?
Knowledge management. What are the variables in knowledge management? Actually, I didn't read.
That is not
Yes.
mentioned here, ma'am. Actually, this is a question which has been raised by one of the participant, and he has written this question only.
Okay.
We can ask the person Umakanji to kindly, give us in detail that what
Yes.
are the variables you are looking at.
Yeah, yeah.
In the meanwhile, ma'am, okay, now we have got another question coming from the same person. In knowledge management research for time series, which variable must be considered? This is what he is asking now.
I may be answered tomorrow, not today,
Okay,
because I will be reading on the knowledge management somewhat, and then I'll be able to answer.
okay, okay, ma'am. Fair
Yes.
enough, ma'am. Yes. There's another question. Any book for marketing application in e-views?
Marketing application in
Yes,
use.
yes, ma'am.
Yes. If you have time series data in marketing, for example, you may see the impact of different uh, yes, like Geo and Airtel, you may take the values of these market share of these companies, and you may check the impact of one on the other. You may apply time series data. There is no such book, no such book on finance. This Chris Books has taken some example of other fields also, not on marketing but other fields, economic field also, because in one model he applied hedonic pricing model, means how the um, prices of rented house, rent of a house are impacted by other in Canadian country, in Canadian area, how the values are impacted by the other, means you may apply. You must be knowing the e-views, you must be knowing the time series, then you may apply it on you may apply on any field, whether it may be marketing, whether it may be HR.
Yeah.
Clear? For example, I'm giving you the these companies, Geo, then Idea, then Airtel, market share of these companies for different years, for different months. You may take if data is available. Then you may check which one was leading in previous period, before Geo, before the introduction of Geo, and after the introduction of Geo. Whether the relationship has changed or not. It is hypothetically changed, or there is actual change in the relationship between the variables. Yes.
Okay, ma'am. There is another question where Dr. Divya is asking, can time series be applied in HR domain?
Yes, in any domain.
Mm.
I just gave an example in the
Just
education
now you have
field.
answered. Yes, yes, ma'am.
Yes.
Mm. There's one question. If found structural breakthrough in data,
Hmm.
how to adjust in time series and how to interpret the result?
Yes. If you find that structural break, then introduce in the same way. I introduced dummy for outlier. In the same way, you may introduce dummy for break. Difference is only at the rate of record, at the rate of date. In dummy variable, it was equal symbol, is equal to. In break, structural break, it is equal to symbol. Then introduce that break in your regression equation, and you may interpret the results whether this is significant or not. If the value of coefficient of this break is significant, you may change, you may interpret that relationship has been changed, and if the coefficient is not significant on the basis of p-value, you may say that relationship has not changed after this particular day. The example I was quoting for Geo, clear?
Yes, ma'am.
Before the introduction of Geo and after the introduction Geo, this may be treated as structural break. Clear? Yeah, I have given this file.
Yes, ma'am.
I
Yes,
have
you have.
already
Yes,
shared
yes.
this file.
We have already
Yes.
shared that. Yes,
Yeah,
ma'am.
yeah. Yes. Next question.
There is one more question. Could you please explain what is temporal ordering with the help of an example, ma'am?
What is?
Temporal ordering. TEMPORAL, ma'am. Temporal
Yeah,
ordering.
means ordering of variables.
We can ask Dr. Rajesh to clarify what is he
Yeah.
looking at actually. This is a question by Dr. Rajesh. Ma'am, in the meanwhile, we can take another question.
Yes.
Mr. Umakant is asking, in knowledge management research, if we are considering knowledge sharing and distribution variable, how
Yes.
time series will be beneficial?
Yes, time series analysis may be beneficial. You may collect the data for different time periods and you may apply time series analysis.
Okay, okay.
Cross-sectional data is not easily available, whereas time series data is easily available on the websites of government,
Mm.
different websites. Yes, time
Okay.
series data is available. Yes.
Ma'am, we'll go back to the previous question where Dr. Rajesh is asking that what is temporal ordering. He has
Yes.
replied yes. You have given him a cue and he is replying to it that yes, he is looking for the same.
Yes, you are looking from the ordering of variables.
Yes, ma'am.
Yes, if we have a single equation model, for example, we will be doing the ARDL model tomorrow or OLS. In that case, ordering is important. Other in var or in error correction model, var ordering is not so much important, but in error correction model, ordering is important, and we will be discussing definitely tomorrow while discussing error correction model. Ordering is most important in error correction model because if ordering is not followed, correct ordering is not followed, results will be spurious. We can't interpret those results.
And
I'll
we are
be
going to,
discussing the
yeah, we are going
ordering
to
in
take
this
that
model.
tomorrow. Yes, ma'am. Okay, ma'am.
Yes.
There's one more question by Dr. Uma Gulati. She's saying, ma'am, we can apply in marketing, but data we do not simply get. Example,
Yeah.
sales trend, but we do not get the data. So what is
Yes.
the answer for this one?
Data are available on the company website. Now the company has to publish quarterly audited data. Then data is available on company website. Quarterly or audited data. Even on list for listed company, these are available on NSE and BSE. Quarterly data is available on NSE as well as BSE. Sales data is available for different companies, listed companies,
Understandable.
and generally we go with listed companies. Yes,
Right. When another question, ma'am, generally we tend to remove outliers, but can
yes,
we study separately outliers or not?
yes.
You already.
We must not remove outlier. We should study separately, and in time series we should introduce the outlier and the results of this outlier. See, I have deleted the results of the coefficient of this outlier will be the impact of that particular date, that particular outlier on the dependent variable. We should not remove because we have now solution for the outlier. We may introduce dummy for the outlier, so we should not remove it. We should introduce dummy for this outlier and we should introduce this into our regression model. Removing is not a good idea. Yes, next
Okay, ma'am.
question.
There is another question like we have got various tools to perform time series. So,
Yes.
according to you, which one is best? EViews or do we have any other?
These are EBS is a software.
Yes,
Models
ma'am.
are different.
No, no,
Models
I am
are
asking, the question is about the tool only.
tool means model or software.
Software, ma'am.
Software. R is best software, but problem with R is it is open-ended. Sorry, open source, and CRAN for the past 1 or 2 years is critically analyzing the uh,
Greater.
you may say that the means anyone in open source software, anyone can introduce its own module. It's not just module, it's code. Sorry, code. Anyone can introduce the code. Now CRAN is doing work on which codes to include and which not to include.
Oh,
Before 2 or 3 years, anyone introduced codes on R and R was doing well. But we must know which code to use. There are so many codes for the same model.
mm,
R is improving very well and R is far better than EViews in the sense that it is open source. We have to pay for e-views. I have full version. We have to pay for e-views, but R is free. That's why R is better. But we must be knowing which code to use for which model. Yes, next workshop in September, I am planning with R.
Oh, great, ma'am. I'm sure we'll all are going to participate in that.
Yeah,
Uh,
you may also organize.
yes, ma'am, sure.
Yes, it will be free.
Oh,
Yes,
okay, ma'am. So,
okay.
Neha is asking
Free
like
from
which tool
from
is
my
good,
side. Free from
right?
my side. You may charge. Yes.
No, no,
Okay.
not at.
Yes, yes.
Yes, ma'am. Neha is asking that which tool is better to perform time series analysis, eViews or Gretel?
In the same way, Gretel is open source.
Okay.
If you are comfortable with Gretel, it is better.
Okay. I think we have got the last question for the day, ma'am. Rajendra sir is asking that graphically we can identify outlier, but
Yes.
how to identify outlier in the data itself?
It is with the help of histogram.
Okay.
In data, see, view, descriptive stat and test. It is histogram and stat. See, there is no outlier in this data because you see that no one is far away from the other values. In the previous one, there was some value from last value was here and some value was far away from this. That we may detect that that was outlier. In this case, we may say that there is no outlier because no value is far away from for the others. There are two ways to detect outlier. We must cross check uh, by graphically presenting and with the help of histogram. We must cross check whether it is outlier or not. Okay.
Okay,
Any
ma'am.
other question?
Uh, I think we have been able to solve all of them, ma'am. I
Thank
think
you.
people are keeping in store for the questions for the tomorrow. And
Okay.
you have already mentioned that what you are going to cover in tomorrow's session.
Yeah, yeah,
So,
yeah.
shall we end it here today, ma'am?
Yes, yes, yes. Thank
Uh,
you.
Okay. Thank you so much, ma'am. And the participants will continue with the session of on time series tomorrow with Sunita ma'am only. And hope to see excitement from the participants end. And in case you have not been able to download eViews, kindly do it. And in case you have any questions related to that, you can drop an email to the mail ID of FDP only. Thank you so much.
Thank you. Thank
And
you.
ma'am, Dr. Uma Gulati is conveying regards to you. Thank you so much,
Thanks,
ma'am.
thanks, Mama. Because of you people, I am always happy to work with Gibbs.
Yeah.
It gives me internal pleasure to
Yes, ma'am.
work with Gibbs. Thank you.
Right.
Thank you all.
Thank you so much,
Thank you,
ma'am.
ma'am.
Pleasure is
Thank
all ours, ma'am. Thank you so much.
you. Okay, okay.
Okay. Okay.